Hi, I'm Shyam Ramesh, and in this video, I'd like to present our recent work, Group Robust Preference Optimization. The motivation of this work is the challenge of fine tuning a large language model to diverse user preferences. Let's begin by discussing an example from the global opinion data. People of different countries are asked their opinion on paying higher prices to address climate change. Now, according to data, the majority of people in Japan prefer to say yes. However, the opposite is true in case of Egypt. Now, in this particular data set, there are more data points from Japan compared to Egypt. Hence, standard preference optimization methods that take a one size fits all approach might align more towards Japan. Our goal is to propose a group robust method that ensures equitable alignment across all groups. We tackle this challenge by the following strategies. The challenge one is that the preference data come from diverse groups. We handle this by including group information in the prompt. Challenge two is that data from different groups vary in terms of size and distribution. We handle this by optimizing for the worst group performance. In particular, we have the following problem setup. We are provided with preference data with group information. We assume that exists a latent reward model that determines the reward for a particular group, prompt, and response combination. Further, we assume that the preferences are derived from the Bradley-Terry model. Based on this, we propose the following robust laws for learning the reward function from preference data. Here, note that this loss is based on the maximum likelihood estimate of the reward model. However, by considering the maximum group loss, we ensure we are optimizing for the worst group's performance. Next, we introduce our group robust DPO objective. The goal in RLHF is to obtain a policy that maximizes the given reward but stays close to the reference model. DPO provides a closed form expression that connects the reward to the optimal policy. We substitute this expression into the robust reward loss and obtain the group robust DPO objective. Here, our GRPO objective measures the policy pi's worst group performance. Hence, fine tuning a language model based on this objective will ensure equitable alignment across all groups. Here, note that the DPO loss can be replaced with IPO loss, hinge loss, etc. Now, the worst group loss minimization can be replaced with a weighted loss minimization from a distributionally robust viewpoint. Hence, this becomes a min-max game where the minimization is over policy SPI and the maximization is over group weights alpha. And the inner objective is here is the group conditioned language policies incurred weighted loss. We propose the following algorithm to solve this objective. The algorithm is of an alternating nature and it performs first gradient descent update on policy parameters theta and multiplicative weight update for group weights alpha. This ensures groups with higher cumulative loss have higher group weights alpha. Further, we analyze the convergence guarantees of our algorithm and provide sublinear regret for log linear policies. In our experiments, we fine tune the GEMMA 2B model with global opinion data and observe that our group robust method attains lower worst group loss and higher worst group accuracies. I'd like to conclude this video with the following take home messages. This is the first study on group robustness in RLHF. Further, to align a LLM robustly to diverse user groups, there is no need for normal losses. Simply using carefully weighted DPO and IPO suffices. If you are further interested, check out our poster on 13th December and scan these QR links to access our blog and paper. Thank you.